Hello. It is always surprising to notice that as far as renewable energy are concerned, in the media, the TV, the radio or the web, there is still a lot of confusion between the units of energy or power. Quite often, journalists could mix up the power of a specific unit, usually given in megawatt, with the amount of energy produced within a year, which should be given in megawatt hour or gigawatt hour. In order to have good basis to start with, I will give, or maybe recall, in this session some useful definitions on power systems, the appropriate units, and give some order of magnitudes. The joule is the standard unit of energy in the international system. It corresponds to the work done when applying a force of 1 Newton through a distance of 1 meter. It roughly corresponds to this. The energy needed to lift an apple by 1 meter. To achieve this simple motion, lifting an apple by 1 meter in 1 second, I roughly developed a power of 1 watt, which corresponds to 1 joule per second. Another daily life example. How much energy is needed to cook some pasta? You will need to boil, let's say, 3 liters of water, and it roughly corresponds to 1 million of joule, 1 megajoule. Hence, the joule and the watt are very small units, which are not really appropriate when you want to quantify the energy or the power at individual or global scale. If you pay your electricity bill, you've probably checked your electric consumption on an electric meter. This model is typical for all flats in Paris. The standard unit used by individual electric meters is generally the kilowatt hour. It is a unit of energy expressed as a product of power, kilowatt, times hour. To give some order of magnitude, 1 kilowatt per hour corresponds to the heat released by a standard electric heater during 1 hour. 1 kilowatt hour corresponds to 3.6 million of joule, 3.6 megajoule. Hence, the kilowatt is a useful unit to quantify the individual energy consumption. For instance, the mean annual energy consumption per inhabitant is about 27,000 of kilowatt per hour in France, and if we consider only the electric consumption, we reach a mean value of 7,000 of kilowatt per capita. In the US, the typical electric meter is different, but the unit to quantify individual energy consumption stays the same, the kilowatt hour. As expected, the mean annual values per capita are higher, almost doubled. Nevertheless, we stay in the same order of magnitude, 10 to 50,000 of kilowatt hour. If we want to quantify the annual energy consumption at the scale of a city or a state, we will generally use the ton of oil equivalent. 1 TOE corresponds to the amount of energy released by the burning of 1 ton of crude oil. As different crude oils have different calorific values, the exact value is defined by convention. 1 TOE equals approximately 42 gigajoules or 11,600 kilowatt hour. In order to give you some orders of magnitude, the annual final energy consumption for Paris is about 5 million of tons of oil equivalent, while for the whole France, we reach 154 millions of tons of oil equivalent. I've quantified here the energy consumption using the term final energy, which differs significantly from the primary energy. If you are not familiar with these distinctions and want to know what represents the primary, the final, and the useful energy, I suggest you to follow the session entitled Primary, Final, and Useful Energy. Thank you.